let's continue solving problems involving natural logs and exponential functions of arbitrary bases. Our first one, and all these we're going to be solving for x. In our first one, we have log base 5 of x is equal to 4. So to do this, we need to get x by itself. So what we want to do is we want to use the inverse property and say, okay, I know that the inverse function for the base 5 log is the base 5 exponential function. So what I can say is 5 to the log base 5 of x is equal to 5 to the 4th power. So I can use each of these as arguments for the 5 to a power. And then what we recognize is, okay, I can actually compute 5 to the 4th hour, 5 to the 4th power, 5, 25, 125, 625. So that tells me that this side is 625. But I also know that this has a cancellation property. Base 5 log and base 5 exponential function are inverses. So that tells me that this is simply x. So simple enough. Now our next problem, we have 7 times 7 to the x minus 6 equals 130. So this one's a little more complicated. So what we need to do is we need to figure out a way to get this exponential function by itself. So the first thing we want to do is we want to divide by that 7. Now what you could have done is you could absorb this 7 into here if you really wanted to. You could say that's 7 to the 1 power and you could add it in. And in fact that's probably a better way to do it. But let's not do it that way, just for extra practice. So if I divide both sides by 7, I get 7 to the x minus 6 equals 130 divided by 7. Now what I could do is I could take the natural log of both sides. Now you could do the base 7 log if you wanted to. But the reason why you probably don't want to do the base 7 log is that if you're going to feed this into a calculator, some calculators have arbitrary bases, but a lot of them don't. So a lot of them only have like the base 10 log and the natural log. So it's helpful to use those as your functions that you apply so that you don't end up having to do another conversion later. So let's use the natural log. So we're going to say the natural log of 7 times x minus 6 is the natural log of 130 over 7. Now what we can do is we can use that power rule to bring this down front. We can say this is x minus 6 times natural log of 7 is equal to the natural log of 130 over 7. Now at that point we have some sort of, this is really just a scalar. This is really just some number here. So let's divide both sides by the natural log of 7. We get x minus 6 is the natural log of 130 over 7 over the natural log of 7. And you might say to yourself, oh, well, these are like natural log and natural log, so I can cancel or combine them, but you really can't. This would sort of be like saying sine of 15 degrees divided by sine of 20 degrees. There's really not a great way to combine those. There's some tricks you can try to do, but for all intents and purposes, you're not that much better off. So finally, to get x by itself, we just add 6 to both sides. So we get 6 plus natural log of 130 over 7 divided by the natural log of 7. And that's really what you have to do. If you're going to put this into a calculator, you kind of have to do it manually here. So if you need a specified precision in a calculator, plug this in, figure out what it is, and then plug that into your homework system. And finally, we have one over here where we're solving another power function kind of like this. So what we want to do is we want to isolate. So notice I said solve for x. Well, in this case I'm solving for t, but hey, what can you do? We need to get t by itself, but t is an exponent. So if the unknown is an exponent, almost always you're going to do things like take a natural log. I say almost always. It's very common that you'll solve these types of problems with natural logs. So what we're going to do is we're going to take the natural log of both sides so we can use the power rule to bring that power down. So if I say natural log 1 plus 0.9 over 365 to the 365t is the natural log of 6. Now I can apply that power rule so I can bring it down front. I can say that's 365t times the natural log 1 plus 0.9 or 365 is equal to the natural log of 6. So what I have here is I have some number times t and then another number. So I need to divide by both of these things. So I can say t is the natural log of 6 divided by 365 natural log 1 plus 0.9 over 365. You know, and I'm not going to lie, that's pretty ugly. Let's think about this for a moment, just to try to give me a second here. Yeah, that looks pretty right. So, as a result, this is going to be your answer. Let me check my notes. It's right. It just looks really wrong. So I apologize there for taking up your time, but that is the right answer. So just hopefully that's helpful, and you'll be able to use that to solve any homework problems you have related to this.